You just installed Bitcoin Core. Your computer has never spoken to another Bitcoin node in its life. There's no central server to call, no master list of participants, no phone book. So how does it find anyone? The answer involves a tiny set of Bootstrap servers, a 17-year-old protocol, and a network that organizes itself like a rumor spreading through a crowd. The answer starts with a surprisingly small piece of hard-coded data. Bitcoin Core ships with a list of DNS seed host names. DNS, the domain name system, is the same protocol that turns website names into IP addresses. When your node boots, it queries these seeds, and instead of returning a website, they return a list of IP addresses belonging to live Bitcoin nodes. Critically, these seeds are operated by several independent volunteers, so no single party controls the entry point. You can override them with the -seed node flag. Important caveat: DNS seeds are not central servers running Bitcoin. They're a phone book, not a network. With a list of IP addresses in hand, the node picks one and opens a TCP connection on port 8333. TCP, Transmission Control Protocol, is the standard reliable transport used across the internet. Geography doesn't matter here. Bitcoin's topology is geographically agnostic, so your node in Tokyo might connect first to a peer in Argentina. Proximity is irrelevant. Once the TCP socket is open, the two nodes perform a handshake, a structured introduction. The new node sends a version message containing 8 fields. The protocol version it speaks, a services flag advertising what it can do, the current timestamp, the remote IP it's contacting, its own local IP, a subversion string identifying its software like /Satoshi:0.9.2.1/, its BestHeight, the height of the tallest block it knows about, and a relay flag indicating whether it wants transaction broadcasts. The peer evaluates compatibility, sends back its own version, and both sides reply with verack, version acknowledged, connection established. One peer isn't enough. The new node now sends an adder message announcing its own IP so others can find it, then sends getheaders to ask its peer for more addresses. The peer replies with a fresh batch of known nodes, repeat with each new connection, and within minutes, a single Bootstrap link blooms into a mesh of 8 or more peers. This is gossip. Information spreads peer-to-peer with no coordinator. Connection established, but now the real work begins, catching up on every block ever mined. Here's the asymmetry. The new node knows exactly one block, the Genesis block, hard-coded into the software since 2009. That's its anchor of trust. From each peer's version message, it saw BestHeight values in the hundreds of thousands. It's missing nearly the entire chain. Downloading hundreds of gigabytes of full blocks from a single peer would be slow and fragile. Bitcoin solves this with a two-phase sync. Headers first, then full blocks in parallel. Phase 1. Headers. A block header is just 80 bytes. Version, previous hash, Merkle root, timestamp, difficulty, nonce. Tiny compared to a full block. The node sends getheaders with its current top hash, and the peer responds with a headers message containing up to 2,000 headers. The node verifies each one links correctly to the previous, appends them, and repeats with the new top hash. After perhaps 140 round trips, the node has the entire header chain, a verified skeleton of Bitcoin's history, weighing only a few hundred megabytes. Phase 2, full blocks. Now the node knows every block hash it needs. It opens a download queue of up to 1024 blocks and sends get data requests to multiple peers simultaneously, different ranges to different peers. 8 peers each delivering a slice in parallel is dramatically faster than one peer serving everything. But there's a catch. Blocks must be validated in strict order because each block references the previous. If the oldest block in the queue stalls because one peer is slow, the entire pipeline blocks. So the node times out that peer, drops it, requests the missing block from someone else, and continues. Step back and you'll notice this whole choreography happens without a single coordinator. A tiny hard-coded list of DNS seeds is the only centralized wedge, and once a node has talked to peers, it remembers them on disk and uses them on the next restart, bypassing the seeds entirely. Seeds are a fallback, not a dependency. Keep alive pings detect dead connections. Slow peers get evicted automatically. Parallel downloads route around bottlenecks. The network self-tunes. This same pattern, Bootstrap, Gossip, Sync, is now the template for every permissionless system that followed. Ethereum, Monero, libp2p, they all inherit this shape. Bitcoin proved that a global database could assemble itself from scratch on any machine, anywhere on Earth, starting from nothing but a hard-coded Genesis block and a handful of host names. No directory, no registrar, just protocol, repeated everywhere, converging on the same truth.